Bae, thanks for inviting me over for our movie date night.
Boy, you know I don't mind.
You know, sitting here gives me ideas. Hee hee hee.
Nathan. No, we have guests, remember. We have to teach the class some things.
I'm sure they won't mind.
Boy, shut up. Before you end up single. Hello everyone, we are here to help our friends Derek and Matthew teach you about some topics learned this first 9 weeks.
Yeah, and it's irritating with our date night.
Anyway, let's first talk about 3 facts dealing with the history of anatomy and physiology.
The history of anatomy begins in 275 BC, when Herophilus teaches anatomy in Alexandria, Egypt, and he also performs dissections of human bodies. Soon in 150 Galen dissects apes, monkeys, cows, dogs. You disgusting. And then writes treatises on human anatomy.
Nathan, did you know that in 1235 the first European medical school was founded at Salerno, Italy? At this point in history here, human bodies are publicly dissected for study.
That's nice. Tanya, but my boy Leonardo da Vinci some plenty years later in 1510 dissects a human and then makes anatomical drawings. Word up, Vinci.
Now let's get over to my friend Derek E. Holmes as we all talk about the anatomical orientation. Take it away.
Yep. We're going to talk about some body directions. So everybody get a move your body, cause it's the anatomical orientational party. Oh, you cannot be tired. So come on, get up and we'll take you higher. Just follow my lead and everything will be okay. We're going to learn some body directions today. The first one as we get started on our way is superior and inferior, that's what I say. From the top to the bottom, from your head to your toe. That's what it is, don't you know? Anterior, posterior, front and back. We are here to help get you on track. So don't you start getting a little slack, even if you think this song is whack. Body directions, body directions, body directions. Move to the beat, to the beat, to the beat, to the beat. Proximal and distal. We got proximal and we got distal. We got lateral and we got medial. Lateral, medial. Now we're moving on to the body cavities. So help me sing along in this activity. We got cranial, we got dorsal, we got vertebral, oh yeah. We got thoracic, we got abdominal, and we got pelvic.
Hey guys. I'm Chris and this is my friend Scott, and today we're going to tell you about tissue in your body. Oh, when you hear about the things tissue does for your body, you're going to explode. So, got too excited. Tissue is a cellular organizational level between cells in a complete organ. Isn't that neat? Animal tissues are grouped into 4 basic types: connective, muscle, nervous, and epithelial. Collections of tissues joined in structural units to serve a common function compose organs. Connective tissues are fibrous tissues. They are made up of cells separated by non-living material, which is called an extracellular matrix. This matrix can be liquid or rigid. For example, blood contains plasma as its matrix and bone's matrix is rigid. Connective tissue gives shape to organs and holds them in place. Blood, bone, tendon, ligament, adipose and areolar tissues are examples of connective tissues. Muscle cells form the active contractile tissue of the body known as muscle tissue or muscular tissue. Muscle tissue functions to produce force and cause motion from the internal organs. And that's not all. Muscle tissue is separated into 3 distinct categories: visceral or smooth muscle, found in the inner linings of organs; skeletal muscle typically attached to bone. Cells comprising the central nervous system and peripheral nervous system are classified as nervous or neural tissue. In the central nervous system, neural tissues form the brain and spinal cord. The epithelial tissues are formed by cells that cover the organ surfaces such as the surface of skin, the airways, the reproductive tract, and the inner lining of the digestive tract. The cells comprising an epithelial layer are linked via semi-permeable, tight junctions. Hence, This tissue provides a barrier between the external environment and the organ it covers. Oh, how I love talking about tissue. Boy, we sure do know a lot about animal tissue, but there is still plant tissue to discuss. I almost forgot about plant tissues. In plant anatomy, tissues are categorized broadly into three tissue systems: the epidermis, the ground tissue, and the vascular tissue. Plant tissues can also be divided differently into two types: meristematic tissues and permanent tissues. Meristematic tissue consists of actively dividing cells, and leads to increase in length and thickness of the plant. The primary growth of a plant occurs only in certain, specific regions, such as in the tips of stems or roots. It is in these regions that meristematic tissue is present. Permanent tissues may be defined as a group of living or dead cells formed by meristematic tissue and have lost their ability to divide and have permanently placed at fixed positions in the plant body. There are three types of permanent tissues: simple permanent tissues, complex permanent tissues, special or secretory tissues. Woo! That was a lot of information on tissues, am I right? Yup. Well, that is all that we have today on tissues and their functions. I hope you enjoyed the presentation and remembered that tissue are very special and important. See you guys later.
Now for your lesson today. You will learn about cells. Cells will be on your exam next Friday, so do take notes. Okay now. Cells are the basic unit of all living things except viruses, because viruses host cells. The cell is the basic structural, functional, and biological unit of all known living organisms. I remember when my professor made it easy to remember what cells were by calling them the building blocks of life. That's pretty neat. Now what are cells again? They're the basic units of all living things and are the building blocks of life? That's right. Cells were discovered by Robert Hooke in 1665, who named them for their resemblance to cells inhabited by Christian monks in a monastery. The cell theory, first developed in 1839 by Matthias Jakob Schleiden and Theodor Schwann, who states that all organisms are composed of one or more cells, that cells are the fundamental unit of structure and function in all living organisms, and that all cells come from pre-existing cells. While the number of cells in plants and animals varies from species to species, humans contain more than 10 trillion cells. Woo! That's a lot to take in. I believe you'll do just fine on the test. Just remember to study your notes. I have another student coming by for an appointment, so we will go over more of this in class tomorrow. Okay. All right. Thank you, Miss Mueller.
Oh, I hope this interview goes well. Okay, let me go over my notes. Okay, so the integumentary system comprises the skin and its appendages acting to protect the body from various kinds of damage, such as loss of water or abrasion from outside. The integumentary system includes hair, scales, feathers, hooves, and nails. It has a variety of additional functions. It may serve to waterproof, cushion, and protect the deeper tissues, excrete wastes, and regulate temperature, and is the attachment site for sensory receptors to detect pain, sensation, pressure, and temperature. In most land vertebrates with significant exposure to sunlight, the integumentary system also provides for vitamin T synthesis. Oh, I am going to forget something. The integumentary system has multiple roles in homeostasis. All body systems work in an interconnected manner to maintain the internal conditions essential to the function of the body. The skin has an important job of protecting the body and acts as the body's first line of defense against infection, temperature change, and other challenges to homeostasis. Okay, so it formats new cells from stratum germanium to repair minor injuries. It protects from UV rays. Regulates body temperature. It also protects the body's internal living tissues and organs. Protect against invasion by infectious organisms. Protect the body from dehydration. Protect the body against abrupt changes in temperature, maintain homeostasis. Okay, I think I'm ready for sure now. I studied and learned everything I need to know to have a good background. Well, here I go. Wait, was the appointment today or tomorrow?
The phalanges bone connected to the metatarsal, and the metatarsal connected to the tarsal, and the tarsal's connected to the fibula. Oh, hear the word of the Lord. The fibula's connected to the tibia, and the tibia's connected to the kneecap. The kneecap's connected to the thigh bone. Oh, hear the word of the Lord. The thigh bone's connected to the pelvis. The pelvis connects to the spine. The spine is connected to the rib cage. Oh, hear the word of the Lord. The rib cage connects to the sternum. The sternum connects to the collarbone. From the collarbone through the spine connects to the jawbone. Hear the word of the Lord. The jawbone connects to your teeth, and your teeth bone connects to your facial bone, and your facial bone's connected to the skull bone. Hear the word of the Lord. The bones, there are bones, they are going around. There are bones, they are going around. Bones, the bones, they are going around. Hear the word of the Lord. And your fingers connect to the metacarpals, and your metacarpals connects to your carpals, and your carpals connect to the ula. The ula connects to the radius, and the radius connects to the humerus, and the humerus connects to the shoulder blades. The bones, the bones going around. Them bones, they are going around. Hear the word of the Lord.